Welcome to the lecture series on high voltage engineering. In this lecture video, we are going to discuss the practical insights about the Marx generator. So, as if you are looking for the how we have arrived at this circuit diagram and what is the working of the Marx generator. This is the circuit of the Marx generator, also known as multi-stage impulse generator. If you are looking for the basic concepts like the working of this circuit, you can refer to my previous video lecture. In this video lecture, we are going to discuss some practical insights about the Marx generator, the working, the role of these resistors R1 and R2, and the role of these charging resistors, wave shaping resistors have been discussed in our previous video lecture in a best possible way, so that you can easily understand everything. So, here we are going to discuss some practical insights. So, these are the charging resistors. So, which type of resistors we normally use? So, these resistors are normally the charging resistors are actually the wire wound resistors, and the fact is that they are actually non-inductive in nature. Because if you are going to make the wire wound resistor, if you have some random wire wound, then inductance may also appear, but these wire wound resistors are non-inductive in nature. I mean to say that they are only resistors and only, and generally the value about these resistors normally they are ranging from 10 to 100 kilo ohm or 1 mega ohm resistors are normally used. Obviously 100 kilo ohm is 100 kilo ohms, but 1 mega ohm resistors are normally used for the charging as a charging resistors. Now, what about the capacitors? Now, the capacitors which you are going to use, they must be those which are of the high current rating, okay, and the capacitors you must choose, they must have less ESR. ESR means equivalent series resistor. The capacitors must be having less equivalent series resistance, and they must be capable of providing the or sustaining the high power. Okay, they must be able of sustaining the high power, because the voltage here is going to be in kilovolts. So, capacitors which we are going to use are in the kilovolts. And about this spacing, we also discussed that this is either remotely controlled or it is adjusted in such a way that it breaks itself once the charging voltage, once the capacitor charges and the voltage is more than the breakdown voltage. So, the capacitors here have less ESR, and their rating are typically around 50 to 100 kilovolt. The capacitors are chosen such that their value, each capacitor can sustain around 50 to 100 kilovolt, but they are high power. So, as well as high power, the high voltage capacitors are normally larger in size. So, how the so in a modern manufacturing procedures, they use actually high permeability. Manufacturers of high voltage capacitors use high permeability dielectric fluids in the capacitors. In this way, the size of these high voltage capacitors reduce. This is not of none of your concern. You actually will buy capacitors from the market. And one more thing which we use in our practical working is the use of the cathode ray oscilloscope. We use CROs because in order to study the effects of impulse waveforms on our insulators which we are going to test. So, these are some points which are very important during the practical consideration, you have to use the CRO, and as I have also told you about the resistors, charging resistors, as well as these capacitors. And one more thing is that obviously why we need RS. This is an important question, that why we need charging resistors here, because because we don't want these capacitors to draw large amount of current from this DC voltage source. So that's why you have used the charging resistors to limit the charging current as well, because we don't want to get this voltage source to burn up, because we are going to generate a high voltage, and for this we are going to charge these capacitors one by one, so that we are not going to burden up this high voltage source. And typically the charging time about this of this circuit is in between practically it is in between 10 seconds to 1 minute. Okay, so let's discuss the first recommended prototype. If you are interested in making the Marx generator in your lab, so how to start? So I will not suggest that you first go with the calculations of wave shaping resistors like R1 and R2 and simulate on the MATLAB. So the first step is to getting things done instantaneously. Like first, let's see, either you are going to develop the waveform or high voltage impulse or not, either we are successful or not. So the first prototype which I will recommend that you can make in your labs is the following, which we also made here, which we also developed. So here you have let's say you have the, so what we had here is the voltage supply, which is around 20 kilovolt high voltage DC. So what we are going to do, obviously we have to charge the capacitor first. So here we connect the charging resistor, and let's say here you are going to connect the resistor, and here obviously you have 200 kilovolt DC supply, and this is the charging resistor. Okay, so this is the capacitor. We are going to connect another capacitor in parallel, and then we must have another capacitor here, and obviously there is the, so these are the three capacitors which we choose. I will disclose the values of these capacitors soon. So then we connected the charging resistors. So here you have the charging resistors, then we also connected here the charging resistors. So we took only three capacitors, and we took the input voltage source of 20 kilovolts, and the resistors, the charging resistors we choose are around 1 mega ohm resistors. We took the charging resistors of 1 mega ohm, and the capacitors which we took here for our experiment purpose are, each capacitor is around 400 picofarad. 400 picofarad. So we took these capacitors and these resistors, and one thing I am missing here, the spark gaps. The spark gaps are here. What we did, we adjusted the spark gaps around 0.5 centimeters. Okay, we adjusted the distance between them around 0.5 centimeters, and what happens here, we took, and here what we had here, so here we took a screwdriver, okay, having a large plastic handle, and we connected it with the negative supply, which is here. I mean, it is grounded. So here is our final spark gap. Okay. So what happens now? Here you have the DC voltage, and why we took this around 0.5 centimeters, because you know that the air has the standard breakdown, standard dielectric strength is 30 kilovolts per centimeter, and practically it is around 20 kilovolts per centimeter. We first adjusted it to 0.5 centimeter. When we adjusted all these gaps around 0.5 centimeter, our experiment was successful, and once we adjusted it to around 0.3 centimeter, what happened? The spark then spark appeared more quickly. So we increased the gap. You can play with this gap, because the breakdown voltage here depends on your condition, because as you know that breakdown voltage of the air depends on the humidity and the temperature of your environment. So what and well, here we have 20 kilovolts, and you have charging resistors as well. So and the capacitors we chosen, they are around they have the capability to sustain the 30 kilovolts. Okay, so these are 30 kilovolt 400 picofarad capacitors. They have the these characteristics. Okay, so I'm removing this 30 kilovolt to avoid any confusion that here either the voltage establishes or not. So here you have 20 kilovolt. What we are going to expect? We are going to expect that here you will get around 15 to 18 kilovolts when we move this screwdriver near to this point. Ideally the voltage here must be 3 times of the input voltage, but practically it is not the 3 times. So sorry, it is not 15 to 18, it is around 50 to 60 kilovolts you can expect here, because 3 times. And here the voltage across these capacitors, it is around 15 to 18 kilovolts you can see here across each capacitor when this circuit works. So this is the basic circuit which you can develop in your lab for the demonstration of the high voltage impulse. And this is the multi-stage generator, and here you have these spark gaps. So once again let me explain the basic working again. These are the gaps which we sorry, here there is no gap. What I have done here, sorry, here there is no gap. Okay, so what happens? First, this capacitor charges up to around, let's say, 18 kilovolts, and once this charges, this gap breaks. All of the sudden, these capacitors also charge, or these capacitors charge simultaneously. Like this is charging, and then this capacitor is getting charged, and then this capacitor getting charged. When the overall voltage reaches around more than the voltage of the breakdown voltage, so these gaps break and you get the spark here. If you will move the screwdriver away, then you won't be observing any spark, because there is nothing to discharge. But when you will move near to here, you may observe the continuous sparking after the intervals of, like, what is the charging time. It depends on your the charging resistor and this capacitor. So this is the basic circuit. You can choose any value of the capacitors. Here you can choose any number of stages. You can choose whatever the charging resistor you want, and then you can start from here. And once you get that these are if this system works, then you can increase the number of stages, as well as you can also apply the test object. Like here you can add your wave shaping resistors, like this R1 is your wave shaping resistor, and then you have the test, and then you have R2, another wave shaping resistor, and we are going to connect the test object in parallel to this wave shaping resistor. So this is the and here you have another gap which is G, and this gap is greater than obviously 0.5. It can be either 0.8 centimeter. First you have to test the breakdown voltage. So once these gaps break down or spark over, then this gap sparks over as well. Either you do this, or either you mechanically break these gaps using some switch. There is another thing which is used to break the gaps, is known as trigatron gap. Now what is a trigatron type gap? We are going to discuss this in our next lecture, in our upcoming lectures, at how to break the gap. The method which you will be using in your labs, in your practicals, you won't be using any trigatron gap in your labs. You will rather rely on the self spark over across these gaps. Okay, so this is about the practical insight. I think nothing more is left with the practical design of the Marx generator. So here we are going to conclude that in our part 1 of the video lecture, we discussed the working of the Marx generator. We discussed the basic circuit diagram, and in our part 2 we have discussed some practical insights about the Marx generator. One more thing here, you will be having the CRO. You can use cathode ray oscilloscope to see the behavior of the impulse waveform, and obviously these R1 and R2 waveforms, as we discussed in our previous lecture, play the role in the wave shaping of the impulse, high voltage impulse waveform. So there we are going to conclude this video lecture, and in our next video lecture we will be here with some new topic. Regards.